So we're joined now by Dr. John Rogers, who is the recipient of this year's Mid-Career Researcher Award. Congratulations.
Thank you, thank you.
What's your reaction to getting the award? A career highlight for you?
Well, absolutely. You know, it's a real honor. We feel privileged and fortunate to have been selected for this award. And I say we because I think an award like this is really given for a body of work rather than to an individual. And at least for the kind of research that we do, it's highly interdisciplinary. We work closely with a number of different senior investigators, students and postdocs and so on. It's really on behalf of them that I'm happy and feel privileged to be a recipient of this award this year.
So the title of your talk is Materials for Electronics That Can Stretch, Twist, Fold, and Flex. So tell us about that. What is it about those properties that, for example, stretching and twisting and so on, that are so important for developing advanced electronic systems?
Yeah, I mean, we think it is an emerging direction and an important future for electronic devices. I'm a electronic materials scientist, and so I'm interested in the future of that kind of technology and different ways that materials contributions can speed the advance of electronics. And if you look at conventional devices, it's been a spectacular class of technology in the sense that it's really evolved in a tremendous way over the last 20, 30 years and will continue to do so into the future, driven primarily by reduction in feature sizes of the individual transistors. So the circuits operate faster, you have higher levels of functionality, the devices get smaller and cheaper. But if you look at the characteristics of that type of technology, it has as an invariant feature the fact that it's always built on the rigid, planar, brittle surfaces of silicon wafers. And that's fine for lots of applications, but if you think about opportunities to bring electronics to bear on important problems in human health, integrate circuits with the human body, that kind of geometry and mechanics is a problem because the body itself is soft and curvilinear and elastic and time dynamic and sort of fundamentally mismatched with the properties of electronic circuits that exist today, which are set by that semiconductor wafer platform. So what we're trying to do is develop similar classes of electronics in terms of their performance and functionality, but with mechanics and geometries that match those of the human body. So electronics that can sort of dissolve and integrate into your skin or wrap the surface of your heart or your brain to provide important diagnostic function that could be useful for surgical procedures or continuous health and wellness monitoring. And that kind of technology really relies on a lot of innovation in materials, electronic materials in particular.
That's fascinating. I haven't really thought about that, but you're right. Is any of that currently in use now, or is that looking toward the future?
Well, we've been active in this area from the level of academic research for the last 10 years or so. There are a number of other groups who are interested in this space as well, trying to figure out building block materials that allow you to make integrated circuits that have the properties of spandex or latex or rubber band go on the body. So I think right now you're seeing the first stages of emergence of that technology from a university laboratory setting into the real commercial world. And we're involved in that technology translation process and a little bit of the commercialization as well. We have a startup company in the Cambridge, Massachusetts area that will launch its first product jointly with Reebok that provides an ability to do the assessment of an impact that you would suffer in sports, like a contact sport like football or hockey, with relevance to assessment of concussions that could happen on the field.
What do you see for the future in this field then? You're focusing mostly on the body. Other applications in the future?
Well, it could be. I mean, there's a lot of interest in flexible electronics, and you're really beginning to see a lot of commercial traction in that kind of space. A lot of large companies are making flexible displays. A stretchable display would represent a natural evolution of that kind of technology. So I think there are opportunities for bringing this kind of approach to bear on more traditional consumer electronic devices. But our real passion and our real interest is in systems that can have a beneficial impact on the way that human healthcare is done.
All right, Dr. John Rogers, what a great explainer. Thank you so much.
Yeah,
and congratulations again on your award.
Thanks again. Yeah.